there. I selected a couple of problems from your 4.1 practice homework titled Solving Systems by Graphing, just to demonstrate the different ideas that were discussed in 4.1. Okay, so the first one we're going to do here is number 2, which reads that we have two lines, y equals negative 2x plus 1 and y equals x minus 2. We're going to be solving each system by graphing, and then we're going to check our solution. Okay? When we're solving a systems of equations, what we're finding is the point, or if there's more than one point, then all of the points, or if there are no points, then none of the points. But we're trying to find the place where these two graphs have a shared solution, a coordinate point, or like I said, more than one or none. But the coordinate point that when I plug it into both of these equations, I get true statements out of both of them. And so when I graph the first one, y equals negative 2x plus 1, I notice that this is in slope-intercept form. So I'm going to be starting at 1. And then my slope is negative 2, so I'm going to be going down 2 and over 1. Down 2 over 1. And I could do this several times if I wanted to. In fact, if I wanted to extend the line back in the other direction, I'd keep that pattern going. And there's my first line. Okay, my other line is y equals x minus 2, also in slope-intercept form, so I'm going to start here at negative 2. And now my slope is 1, so I'm going to be going up 1 over 1. And right there, I already see that that's going to be my shared point, but let me keep the graph going. I know it's my shared point because I literally touched the same point, right? There's my other graph. And so my shared solution, the place where these two lines intersect, is at this coordinate point, which is at x equals 1, y equals negative 1. So my answer is going to be 1, negative 1. Okay, well, to check this solution, like I said, when we plug 1, negative 1 into both equations, I should get a true statement out of both of them. I should see that it is, in fact, a solution. And so let's go ahead and check that. When I plug 1 into my x value, because that's what my x is 1, so I'm going to plug 1 in here, negative 2, and then 1 instead of x plus 1. If this is a true solution, then I should get negative 1 as my answer. And sure enough, I do. My y is negative 1. And when I do it on the other one, plugging in 1 into this x coordinate, 1 minus 2, I get negative 1 again. And so this point is a solution for both of these equations, as seen in the graph as well. Okay, number 5, very similar. Number 5, two slope-intercept equations. We're starting at 2, which is here. My slope is negative 3, so I'm going down 3 over 1. So there's my first line. And then my second one, I'm starting at negative 3 and going a slope of 2, which means up 2 over 1. So up 2 over 1, there's my shared point. I already know that's going to be my intersection. We'll go ahead and finish the line out. So I can see the shared point is right here, which is at x equals 1, y equals negative 1. And one more time to check our answer. For this to be the right answer, I should be able to plug 1 into my x's spots and get my y coordinate, which in this case is negative 1. Well, when I plug in 1 to that top equation, negative 3 times my x plus 2, I do get negative 1. And when I plug in my 1 into the bottom equation, 2 times 1 minus 3, I get negative 1. And so I know, because I got negative 1 on both of them when I plugged in 1, that I do have my right answer. Okay, the last 3 problems we're going to do all revolve around the idea of one solution or infinitely many solutions or no solutions. okay, which is the other piece of 4.1 that we discussed. Up here on numbers 2 and 5, both of these have one solution because there was one point where both lines touched, where they intersected, a common coordinate point. And so there was one solution. In this case, both of them were 1, -1. But it is possible to have no solution or infinitely many solutions. I would be no solution if my lines never touched, right? Which would mean parallel lines. Well, back in Unit 3, we learned what it means to be a parallel line. Parallel lines mean they have the same slope. And so that's what I'm going to be looking for. If I see that they have the same slope and they aren't the same line, I'm going to be no solution. Which brings us to the idea of infinitely many solutions. Well, if you have infinitely many, that means they share every point. Not just one, like numbers 2 and number 5 above, but infinite. Right? All of the points they have in common. Well, what does it mean for two lines to have all of their points in common? It means those two lines are the same line. That when I graph one and then graph the other, the second one sits directly on top of the first one. That would be infinitely many solutions. And so to identify this one, we're going to look for the equations to literally be the same equation. Right? So this says, without graphing, decide whether the following system of linear equations has one solution, infinitely many, or none, and explain. Well, the explanation is what we just talked about. It's going to have one solution if they're two distinctly different lines. They're going to be infinitely many if they're the exactly the same line. And they're going to be no solution if they're different lines except that they have the same slope. Okay? As I look at these two, y equals 4x, it's easier for me to identify what its slope is, right? Because it would be no solution if these two lines have the same slope. This equation's slope is 4. But this equation, I can't really see my slope right now. This isn't really in a form that I recognize. And so in my mind, I'd like to turn this into y equals mx plus b. Because if it was in y equals mx plus b, then I could identify what my slope is. My slope would be this m. Well, we did this in Unit 3 as well. If I had this 8x equals 2y minus 16 that they gave me, to turn it into slope-intercept, the difference between these two is, first of all, I notice that y doesn't have anything added or subtracted to it. Over here, I have a minus 16 attached to my y, so I'd like to get rid of that minus 16. So I'm going to add 16 to both sides. I'm going to get 8x plus 16 equals 2y. Once I'm there comparing the two, I notice that y is entirely by itself. It has no coefficient. Over here, my y has a 2 attached to the front of it. So to undo that multiplication, I'm going to divide by 2. And I'm going to get y equals, so that's what I'm left with over here, 8 divided by 2 is 4. 16 divided by 2 is 8. And now I can see my slope. My slope is 4. So which of these three is this problem? Well, this problem, since they both have a slope of 4, but they aren't the same equation, this one's just 4x, this one's 4x plus 8, then I know that it's going to be no solution. It's no solution because my two lines have the same slope of 4, but different y-intercepts. Okay. Let's go ahead and do two more. Back to graphing. Numbers 15 and 16. Okay, number 15, we have a standard and a slope-intercept. So you can graph them in either order. I'm going to go ahead and graph my standard first. So to graph in standard, first of all, you could choose to turn this into slope-intercept if you wanted to. Right, that would be fine. But I'm going to go ahead and graph it as a standard form. So I need my x and y-intercepts. So y-intercept is when x equals 0. So we get negative y equals negative 2, which means if I divide this negative over, y would equal positive 2. Well, y equals positive 2 right here. Okay. My x-intercept is when y equals 0, so I'm going to go ahead and cover up that y there. And I get 3x equals negative 2. When I divide that 3 over, I get x equals negative 2/3. Negative 2/3 is right here. And so there's my line. Okay. Slope-intercept. We're going to be starting at 2. Oh, and there's my shared point. And then I'm going to be moving down 1 over 2, down 1 over 2, because it's negative. So down 1 over 2, down 1 over 2. I could keep it going the other direction if I wanted to. And I get my second line. So to solve this one, our directions are solve each equation, or sorry, solve each system by graphing. Tell whether the system has one solution, infinitely many, or none. Well, this one would have one solution because it intersects one time, and that solution is at that coordinate point, which is your y-intercept, x equals 0, y equals 2. And last but not least, number 16. Okay, number 16, we again have a standard form. So x-intercept is when y equals 0. So my x-intercept is 2x equals 5, or dividing that 2 over, we get x equals 5 over 2, which is 2.5. It's right there. My y-intercept is when x equals 0, so my y-intercept is y equals 5, which is up here. Okay. And connecting that, we get our line. Yep. This 2y minus 1 equals negative 4x plus 9 is a little bit wonky. This isn't any form I know. So you have a couple of options. You could turn it into slope-intercept, y equals mx plus b, or you could turn it into standard. Personally, I probably would pick to turn it into standard. It's just a little bit easier for me, but again, you could do it either way. So to turn it into standard, I know I need to get it into this form, ax plus by equals c. Which means my x and my y need to be on the same side of the equal sign. So I'm going to go ahead and add this 4x over to the other side. Positive 4x. And then the 2y minus 1 equals the 9 left over on this side. And then the other thing I notice is it's just the x and y on this side, no other numbers here. And so this minus 1 needs to be brought over here. So I'm going to add 1 to the other side. And I get 10. Okay, we're graphing this equation then. Standard form. My x-intercept is when y equals 0. So my y equals 0. Or sorry, x-intercept is when y equals 0. Let's cover up our y. So 4x equals 10. Which means dividing that 4 over, my x would equal 10 divided by 4, which is 2.5. Oh, which is that same point. And when I do my y-intercept, x equals 0, so I'll cover up the x, and I get 2y equals 10, and dividing that 2 over, we get y equals 5, which is the same point. And so when I connect to these 2 points, I get the same line. They're the exact same line. And so what does that mean? Well, it means that I have infinite solutions. Because every point on that line is a solution. And there you go.